Hi guys, and welcome to today's video on Year 8 for similar figures. Yes, we have been dealing with geometric reasoning for a number of videos now, and if this is the first time you've joined, don't worry about it. There's loads of videos for you to watch on MaffsGuru.com or my YouTube channel. But those of you who have been keeping up, we've dealt with congruence, we have dealt with all sorts of exciting stuff. Now we're dealing with similarity. Very, very similar to congruence, whereas congruence was the same. Similar is basically the same but bigger. It's where we take a shape and we multiply all of the sides by the same number. Awesome stuff, but let's not rush ahead from ourselves. If you are new to my channel, hi and welcome. If you can do me the honor of, over in that bottom corner is a little button that asks you to subscribe. And if you do that, it lets me know you're watching. I sit in a room slightly weirdly talking to myself, hoping that people will actually subscribe. And if you can do that and get a couple of your friends to do it as well, it actually makes it all worthwhile. Otherwise, I'm going to go mad. So what am I going to look for by the end of this lesson? It's above and what it means for shapes to be similar and how to work out scale factor enlargements between two shapes which are similar and use that to find missing sides of shapes as well. So, as I said a moment ago, we have looked at the idea of congruence in previous lessons. And with congruence, there are a number of rules and bits and pieces that you needed to know. And there was the SSS and the AAS. Well, the good news is, not needed. Not needed for that at all. We only need to know about a certain number of things for scale factor enlargements, and that's the side lengths or angles inside. So, similar figures, as far as I can see, and I am telling you, ladies and gentlemen, is that they are those where one shape is basically an enlargement or reduction of the other one. It's like I've taken it and stretched it or compressed it, and they are similar figures. Again, it doesn't matter if I flip it or turn it, so long as when I look at these things I go, yep, they are definitely similar, then I will be as happy as Larry. Who is Larry? Anyway, maybe we all know a Larry. So if we look at the following example, I'm going to ask you a question. Are they similar? Is one shape bigger than the other? And hopefully you're going to turn around and say, well, yeah, absolutely. This shape here, this shape number 2, and if we call this shape number 1, shape number 2 just seems to be shape number 1, which has been flipped, you know, or reflecting in some sort of horizontal sense. But it would appear that they are in fact similar. One is bigger than the other. But hold on a moment. Which one is the original shape and which one is the image? Now, interestingly, in maths, we tend to always think the shape on the left is the original and the shape on the right is the image. And you're going to go, what's this image you speak of? Well, when you look in a mirror, what do you see? Hopefully you see your mirror image. So you are the original, and that imposter on the other side of the mirror is your image. So we always call shapes with original, and we call the others the image. Now in that situation, if I've got the original as the smaller shape and the image is the larger shape, well, then we know it's been enlarged. But if I swap it the other way around and make this my original and that my image, well, what's actually happened? Well, this is what I'm saying here. So when you look at these things, you've got to know a certain amount of information. Sadly, looking at those two shapes, I don't know. Looking at these two shapes here, I just don't know which is the original and which one's the image. So making shapes have side lengths. So if I've got side lengths on, that actually makes my life a lot easier. Because I can now look at these two shapes and go, well, hold on a moment. They seem to be similar. I'm going to write on here that this is my original, and I'm going to write on here that this is my image. So that means I'm definitely getting bigger. Here's a question for you. Which side then matches that 3 on my image? Which side matches that 3? Well, hopefully, if you realize that shape number 2 here is just shape number 1 flipped that way, well, actually, the 3 and the 6, those sides match up. What about this 4 here? Who does that match with? Well, it was on the bottom, and if I reflect it, it's going to be 8. So we've got 3 has gone to 6, 4 has gone to 8. What about this 6 here? What does that match up with? Well, fingers crossed, the 12. So 6 goes to 12, and then finally 2 has gone to 4. And every one of you out there should now be screaming at me going, well, hold on a moment, they're all doubled. And that's the trick to similarity. If every single side has been multiplied by the same number, has been doubled or tripled or quadrupled or multiplied by 1.5, because we can have decimals, then they are similar. Whoop, whoop. But here's an interesting question. what on earth would happen if that was my original and that was my image? Well, in this situation, we've gone 6 would have gone to 3, and 8 would have gone to 4, 12 would have gone to 6, and 4 would have gone to 2. And you're probably sitting there going, well, that isn't difficult. I've just halved it. And then I'm going to go, yes, you're right, but sadly, scale factor enlargements. So when we look at enlarging, or when we look at the scale factor by which these things have grown, it's always got to be a times. Yeah? So whereas in this situation here, we could say it was times by 2, what would I multiply 4 by to get to 2? What would I multiply 12 by to get to 6? And hopefully you would realize in that situation, I would multiply by a half. Now, depending on how good you are with multiplication and division, hopefully you will realize that when I divide by 3, that's the same as multiplying by a third. When I divide by 4, that's the same as taking a quarter. You see what I'm doing there? That type of stuff is critically important because scale factors have to be timeses. Right, let's have a look at this one here. Look at the following example. Let's enlarge the shape by a scale factor enlargement of 2. So when it says scale factor enlargement of 2, it just means take all the sides and double them. Right, so I'm going to draw a diagram roughly twice as big. And you're going to say that's nowhere near twice as big, but math is great because scale diagrams, we don't know what you're doing anyway. So if I'm enlarging it by a factor of 2, everything in that thing gets doubled. So what do I have here? I have 6 and 6 and 8. And if that was the case, I would write O for my original and I for my image, and I am great. Thank you very much. Now I'm going to ask you a question in a moment about the size of the angles inside. When I double the size of the shape, do my angles double as well? Because the sides are doubling, don't the angles double? Let's go back and say now, what happens when we have a scale factor enlargement of a half? Well, we just talked about this a moment ago. Now, when we're multiplying things by a half, we're making them half as big. So if this is my original, scale factor enlargement a half is actually going to make the shape smaller. So I've got 10 centimeters here, which I want half of. So that's going to be 5 centimeters there. 18 centimeters there, which I want half of, which is 9 centimeters. And I'm going to do 1, 2, 3, 1, 2, 3, and let's do 1, 2, 3, 4, and 1, 2, 3, 4. Now the reason I'm doing that, interestingly, is because some of my students said, well, can we put 1 mark and 2 marks? And when I think about it, probably not. That 1 mark means that this side and this side here are the same length. If I then put 1 mark on that other diagram, then it would probably infer that that then would also be 10 centimeters, but it can't be. We've done that. So multiplying by a half is awesome. It's just as easy as everything that we've got. So I said a moment ago that I'm going to ask you about the angles inside. Here we go. Here is a shape. This is my original, and here is my image. Now, because we've got these little marks on them, it means the triangle is equilateral. And because I've got the same little double marks, or I've got double marks here, this triangle is also equilateral. It doesn't look like it on the diagram, but they're not drawn to scale. So if this is 4 centimeters and this is 12 centimeters, I know that they are similar. And I know that to go from 4 to 12, I'm timesing by 3. So here is an angle there is 60 degrees, there is 60 degrees, and there is 60 degrees. And if I'm multiplying everything by 3, then surely that now becomes 180 degrees, 180 degrees, and 180 degrees. And before I'd even finished that first one, you were like, no, that can't be right. And that's one of the huge tricks in mathematics. Oh, just drawn it and rubbed out half my shape. When you make similar shapes bigger or smaller, the angles inside stay the same. Otherwise, you'd end up with triangles with like 540 degrees, and that just doesn't make any sense. Right. How do you work out the scale factor enlargement? Well, just as easy, ladies and gentlemen, because there is a formula which I am going to scroll onto the screen here now. Scale factor enlargement basically says always take one length of the image and divide it by the same length on the original. That's all you need to do. Right, so looking at this one here, we have an original and an image. So we've got 4 centimeters here on my original, we've got 20 centimeters here on my image, and the formula says my scale factor enlargement is given by the length of my image, which is 20, divided by the length of my original, which is 4, and hopefully every single one of you will know to cancel that down. You must cancel fractions down. because if you don't, sadly, you lose shed loads of marks in mathematics. So that was nice and easy, and it doesn't get any harder than that. What about this shape here, reductions? A reduction is just a multiplier, which is effectively smaller than 1 but greater than 0. So again, the formula says that the scale factor enlargement is equal to a side length of my image divided by a side length of my original. Right, so let's choose some comparable sides. Well, I'm going to choose this side here and this side here because they're obviously corresponding. So let me see, my image is 6 and my original is 30. Now again, be careful, 6 divided by 30 is not 5. If I've got 6 sweets and 30 friends, they're not going to get 5 each. And because I know that 6 is going into there once and 6 is going to there 5 times, I now know that my scale factor enlargement is 1 on 5. Now, for this to be a true similar shape, I really should be checking every single one of those sides, because maths, being a big fat trick, they may actually have that 3 of the sides are in fact similar, but 1 of them isn't. And in this situation, all 4 sides would have to be multiplied by the same value of 1/5 for it to be similar. Right, here are some examples taken from the Cambridge Essentials textbook series. Thank you, Cambridge, for letting me use your examples. Right, for the following pair of similar figures, complete the tasks shown, A, B, C, and D. Okay, A, show the pairs of corresponding sides. So the first thing I need to do is look at shape number 1 and shape number 2. Now, which one's the original and which one's the image? For this particular question, we will assume the original is the one with the A, B, C, and D, just because the letters are actually earlier in the alphabet. And how have they gone from shape 1 to shape 2? How have they done this? Well, it would appear they've actually flipped the shape that way. All right, so we now know that. So list the corresponding sides. It's saying, well, looking at the sides on the shape that we've got, my original, we've got AB, we've got BC, we've got CD, and we've got DA. Now, because we're being asked to find corresponding sides, the order of the letters is important. So now, AB must be equivalent to EF, not FE, because we have to swap the shape around. Next one, BC would be equal to F and G. CD would be equal to GH because G comes there. And then DA would be equal between would be HE. And there we go. So there are my sides that are corresponding. Part B, list the pair of corresponding angles, or list the pairs of corresponding angles. That's just saying, well, which angles in which shape are the same? Well, angle A in that situation would be the same as angle E. Angle B would be equal to angle F. And notice I'm using that angle sign. That's not an L, it's an angle sign. And be very careful. I've got angle C, lol, would be equal to angle G, and that would leave that angle D would be equal to angle H. And my angles are looking more and more like L's. Try that one again. MaffsGuru, which gives you angle H. That looks like a Z. What is going on today? Angle H. And there we go. There's part B. Find the scale factor. Now, the scale factor tells us that we've got to find. Now, I know they didn't say enlargement, but it's still asking for the scale factor. So scale factor enlargement, we need to choose 2 sides that correspond and have measurements on them. And as it turns out, we've got a 2 centimeters here and a 6 centimeters here. In fact, they are the 2 sides that correspond. So, bearing in mind this is my original and this is my image, my scale factor enlargement is my image divided by my original. So my image would be 6, my original would be 2, and writing that down, my scale factor enlargement would be 3. Now it says to find the value of the pronumerals. Pronumerals in maths are letters. And so what they're saying is, can you find now the value of y? Let's just delete that for a moment. Let's say what they're saying is, can you find what y is, and can you find the value of x? We can do that, I think. Thank you very much. So let's do x first because it's first in the alphabet. We know that CD is equal to 1 centimeter, and we know that the corresponding side is GH. And we know that to go from the smaller shape to the bigger shape, I'm going to be multiplying by my scale factor enlargement. So that is going to be 1 times 3, which gives me 3 centimeters. Right, what about my other one? Well, we know that AB is equal to y centimeters. And we know that the corresponding side to that is EF. which is 6 centimeters. Now in this situation here, remember, EF is the enlarged shape. So what I'm saying is, what number, when multiplied by 3, gives me 6, and in which case y in this situation would be equal to 2. Yay, 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 yay. Decide if these shapes are similar by considering corresponding angles and ratio of sides. Well, if we look at this first one here, while the diagrams aren't necessarily drawn to scale, what we do notice is that this side here seems to correspond with that side there. Yes? So how do we go from 7 to 7? We multiply by 1. So for shapes to be similar, we would need to have that this would multiply by 1 to give me that. And I don't know about you, but 3 centimeters times by 1 isn't 14 centimeters. It actually doesn't matter if I rotate those shapes around. Somebody asked me to do that today. Okay, so let's have this bigger one here, still as 7 and 14. And let's rotate this shape around here then, and have 7 there and 3 there. Well, 7 to 14 now becomes times by 2. But again, when I multiply by 3 by 2, it doesn't become 7. So those shapes are not similar. What about these two shapes here? Well, it's almost like the example I did earlier. We notice that because of these little marks, triangle ABC is equilateral. We know that these little marks here are equilateral, which means all the sides are the same. And so can I go from one shape to the other? I should COCO, because my scale factor enlargement will be equal to, well, assuming this is my original and that's my image, 2 divided by 5. I'm just choosing one of the sides is 2, divided by one of the other sides is 5. Can I cancel down 2 on 5? Nope. And so there we go. There is my example done. Now, actually, that was Year 9 Maths at Similar Figures. And there we go. That is the end of this video on similar figures. Yay, we're about to move on to the Year 9 work, and those videos will be uploaded soon. Thank you so much for taking the time and watching. Now, if you haven't already done so, over there in a moment will be a circly thing that will allow you to subscribe. Please do so. Again, really helpful if you can. Below that doohickey is a video loading, also at a Year 8 standard, so you might want to watch that as well. I am stoked that you've made it this far. Thanks very much for your time. I am signing off, and we'll see you in our next video. Take care. MaffsGuru out.